All right, hi, welcome. I'm about to work through this study guide for chapters 2 and 3 in Algebra 1. And I'm going to start by copying this little thing and putting it, whoopsie, I'm going to put it over here. I'm going to rework this here. Now, I would start with the common denominator. There's a lot of ways to do this. I prefer to just get rid of the fractions by multiplying by 14. Now, further, 14 times a half is 7. But I think it's also helpful to think of 2 going into 14 7 times, and 7 times 1 is 7. So that's 7x. There's that. 14 times 3, what? 42? 42 minus 42 equals, and the last one's going to be 8, right? Multiplying that. So we get, what, 7 goes into 14 2 times, and 2 times 4 is 8. I'm just making sure that 14 times 3 is 42. Okay, so then I would add 42 to both sides, and 7x equals, what, 50? So x is going to be 50 over 7. I'm okay with improper fractions. That would be all right. Okay, next. For this one, oh, I could do it over here actually. I'll copy this right here and put it, oops, over here. Okay, I would get rid of the fractions again by multiplying both sides by 5. On this side, the 5's would cancel, and I'm left with x plus 3. And over here, 5 times negative 15 is, what, negative 75? And if I subtract 3 from both sides, I get x is equal to negative 78. And yeah, that sounds good to me. For this one, I will copy again, bring it over to the side. And I think that perhaps I could distribute the 2/3, but I think I'm just going to multiply by 3/2. So if I multiply by 3/2 here, these cancel, but I have to multiply by 3/2 over here. So it'd be x minus 18 equals what, 21/2? And then if I add 18, and if I express 18 as a number of halves, so we have a common denominator, that's 36/2. So 21/2 plus 36/2, that would be 57/2. So, whoopsie. Why did that happen? X would have to be 57/2. Okay, next, this one. I will copy and put it over to the side right here. And I would multiply by, what, 20 is the least common denominator? So I'd multiply here. 4 times 20, I'm sorry, 4 goes into 20 5 times, and 5 times this, I'll just write it as 5 times 4x plus 2. And then 20 times that, well, 10 goes into 22 times, and 2 times 3 is 6. So that equals 6. I guess I'll distribute the 5 to each of these items. That would be 20x plus 10 equals 6. And if I subtract 10, I get 20x is equal to negative 4, right? So x has to be negative 4 over 20. Oh, which is negative 1/5. Great. We simplify when we can. Okay. Next. Ooh. Yeah, this one's definitely beefy. Order of operations question. So I think that what I would do is I would show that we have, what, the absolute value of negative 4 plus 2 times 6 is 12 over 4 squared is 16 plus 11 minus 2 times 8 is 16. Absolute value of negative 4 is 4. Oops, 4 plus 12 over, this should be just 11, right? This is 27 minus 16. And then that would be 16 over 11. Yeah, just keep it improper. Why not? Okay. Solving literal equations. Got to solve this for y. I'm going to want to isolate y, so that means I'm going to subtract 12x from both sides. And I'm left with negative 4y is equal to negative 12x plus 20. I can't add these two terms together. I can only write them next to each other. The last step is to divide by negative 4. And I don't know, I could write this a couple ways. I could divide each item by negative 4. It works out because 12 is divisible by 4, and so is 20. So these cancel, and y is equal to negative 12 divided by negative 4 is positive 3. X, negative 20 divided by negative 4 is negative 5, and there you go. There is that final answer. Solving this one for b, I think that what I would first do, I think I'm going to have to write this, copy it over here. Okay, so I would multiply both sides by 3. When I multiply this by 3, I just get a plus b plus c. Okay, and then this right here is 3 times big A. It's trying to solve for b, so let's subtract a and c, minus a and minus c. And what I have on the right hand side is b, exactly what I wanted. And then I have 3 capital A minus little c. And that would be it. That is solving for b. On this one, I think I'm going to need a little bit of space for this one. So I'm going to, and I want to solve for y on this one. So what I would do is I would subtract a over b, right? And maybe I would write it this way. I'd probably write it like this: minus a over b minus a over b, and I'm left with negative c times d plus y equals x minus a over b. And then I have to divide by negative c, right? Divide by negative c, divide this by negative c, and I'm left with d plus y equals x minus a over b, all divided by negative c. Wow, this is going to be a mess after this. Finally, I have to subtract d from both sides. Maybe I'll subtract d over here, and I get y is equal to x minus a over b over negative c minus d, just like that. Wow, that was a little crazy. I'm going to move all this over. Okay, maybe I'm not. I'm trying to. It won't let me. I'm going to, let's see, I'll solve this one here. Maybe I'll do it in red. This one's easy. You subtract 10, right? X is less than negative 2. So we have negative 2. It's going to be open circle because I don't have an extra line right there. And less than negative 2, that is like this. There it is. For this one, yeah, you just got to divide by 4, right? That's easy. And that would be, what, negative 3 is less than or equal to x. So we have negative 3, which is colored in because we have that extra line right there. And x is bigger than negative 3. Done. Just like that. Okay, so number 15. I think I'm going to just copy and bring it over here. I'm going to, let's see, I'm going to divide it by 3/4. Excuse me. If I divide by -3/4, I would have to divide this by -3/4. And x, got to switch the direction of the inequality. Okay, 12 divided by 3/4 is the same thing as 12 times 4 over -3, which is 1. What, 4? -16. So I didn't make this big enough, so let's make this -16, close circle, and going to the left. Compound inequalities. The only thing I really need to do is subtract 1/2 from all sides. -1, subtract 1/2, subtract 1/2, subtract 1/2. So that's what, -2 and 1/2 is less than or equal to x, which is less than what, -4, or just 4, right? So 0, 1, 2, 3, 4, and it's an open circle there. And here's -2.5, closed circle here, and a line that connects them. Great. I would multiply everything by 9 first. So if I did that, if I multiplied this by 9, that's -27. It's less than or equal to 6 minus x is less than or equal to 27, right? Subtract 6 from all of these. You get -33 is less than or equal to -x, which is less than or equal to 21. All right, divide by -1. Divide everything by -1. That switches directions of all the inequalities. So that means 33 is greater than or equal to x, which is greater than or equal to 21. So x is, so, you got 33 somewhere around here, and you got 21 somewhere over here, and it's closed circles in between those two. There you go. 18. In number 18, there is, we got to add 3. And we get 5x is greater than 10. So x is greater than 2. And add 6. So 4x is less than -4. So x is less than -2. So x is greater than 2. So we can do 0, 1, 2, -1, -2. It's smaller than -2 with an open circle. And it's greater than 2 with an open circle. Okay. Number 19, absolute value quality that has 4 and 5 as its solutions. Okay. Let's go. Let's see. Absolute value equality that has 4, -5 as 2 of its solutions. So I wonder, what's right in the middle of those two? 4, and that's 9. So -1/2. I wonder if I have x. For a moment I was thinking it was absolute value equation, which would be pretty tough. But an inequality, let's go with x plus 1. Absolute value has to be greater than 1. -5 plus 1 and 4 plus 1. There you go. That's it. Because if I put -5 in here plus 1, that would be absolute value of -4, which is definitely greater than 1. That checks. And then the other one would be the absolute value of like 4. Okay, so if I put 4 in here, 4 plus 1, absolute value of 4 plus 1 is 5, which is greater than 1, which also checks. So this would be one answer. I mean, there's so many different ways to do this. That's just one. Oops. I meant to move this up. 2 buildings have the same total height. One building's 8 floors, has 8 floors with a height h. Okay, so that's 8h. That is 8 times h. The other building has a ground floor of 16 feet, so that's what are the height? Oh, so what is h? The other one is 16 feet. Oops. 16 feet plus 6h. So if I solve for h, 2h is equal to 16, so h is equal to 8 feet, whatever, feet. Super. At Silver Gym, membership is $25 a month. Personal training is $30 each. Okay, so $25 per month and $30 for each session. Okay, we're talking about the total cost for in 1 month. So that means the 25 is not going to have a variable because that's how many months. We're just talking about 1 month. But the number of sessions, that's the variable. We're trying to figure out how many sessions they're going to be equal. And then what the other one? $65 per month plus $20 for each session. There is our equation. So we subtract 25. Subtract 25. You get 30x is equal to 40 plus 20x. Subtract 20x. And 10x is equal to 40, so x is equal to 4. 4 training sessions. Adele opens an account with $100 and deposits $35 per month. When he does opens an account with $50. So $100 starts and $35 per month. The other one is, so when is this equal to depositing $50 and adding $35 a month? So X. After how many months? There's no solution. They will never have the same amount. Because of the 35, they're both going at the same rate, $35 every month. They stay the same distance apart from each other. They're never going to be the same. Okay. Let's go to this, solving proportion problems. I guess you could multiply both sides by 9. I mean, that's fine. So if you multiply both sides by 9, this would just be x minus 2, because the 9's cancel. And 3 goes into 9 3 times. 3 times 2 is 6. So you add 2, and x is equal to, 8. Here you can multiply both sides by 42. Multiply this by 42, and 7 goes into 42 6 times, so it's 6 times x plus 3. And the other side, 6 goes into 42 7 times, so 7 times that. 7 times x minus 2. So 6x plus, 18 is equal to 7x minus 14. Subtract 6x. And you got to add 14. So I think I'll just do that all in one step. So that's, 32? 32 is equal to x. Super. This one's tricky. This is good. I think I better just do this a little bit differently. Like this. I would multiply this side, do that kind of butterfly thing. So it's x times 4x minus 3. And then multiply those two together equals 4 times x squared plus 1. X times 4x is 4x squared minus x times 3 is 3x. 4 times x squared is 4x squared, and 4 times 1 is 4. If you subtract 4x squares from both sides, then you get negative 3x is equal to 4, so that means x is equal to 4 over negative 3. Okay. 26 is, well, what I would do first is I would subtract 4. Negative 3, absolute value x plus 2 is greater than negative 18. Divide by negative 3. And the absolute value of x plus 2 is less than, gotta switch it, right? Because you divided by a negative, less than positive 6. So x plus 2 is less than 6, and you got to do x plus 2 is, got to switch it now, and the next negative version of 6, which is negative 6. So you subtract 2. X is less than 4, subtract 2. X is greater than negative 8. 2 answers. That's an or. Yeah. Okay. Going to 27. You gotta subtract 3/4. Subtract 3/4. So if you have absolute value of x plus 1/2 is equal to negative 3/4, there's no solution. Because you can't take the absolute value of something and have it be negative. Okay. Here we have, so when we do this, we have the positive version, so negative 3x is greater than or equal to 6.3, and negative 3x now divided by negative 1, so it's switch that, and negative 6.3. Okay, so x is going to be, oops, not equal to. How about I just divide by negative 3? So x is less than or equal to, what, 2.1? And then divide this by negative 3. And x is greater than 2.1. Actually, okay, or equal to, right? Equal to, I forgot actually negative right there, so that makes a big difference. It's smaller than negative 2.1, and it's bigger than regular 2.1. Okay, that's good. What are the subsets of B? Okay, subsets of B are, well, it's always the null set. And it's comma 8, 12, 4, 8, 4, 12, 8, 12, and 4, 8, 12. Okay, that sounds good. Okay, the next part. Well, what's the complement of B? Well, it's everything that's not, okay, it's this is called the complement. So we look at B, and we look at the universal set. Okay, so we know that 4 is in set B, and we know that 8 is in set B, and we know that 12 is in set B. The complement is all the other stuff that I'm about to underline in blue. That's the complement of B. So that would be 1, 2, 3, 5, 7. 15. Is B a subset of A? No. Oh, is the complement of B? Oh boy, is the so is the complement of B? So is this a subset of A? I'm going to say no. So I'm going to say no. No, because oops, the oops of boy, my iPad's going absolutely bananas. No, because all the elements of complement of are not in A. So no, because all the complements, all the elements the complement of B are not in A. So there you go. Okay. For number 32, express each set in set builder notation. Well, we're just rewriting the set. What are these numbers? We have 0, 1, 2, 3, 4, 5, 6, 7. Well, it looks like they're whole numbers, right? The whole number is up to 7. So we're going to rewrite this as the set A is equal to, we set our variable as x such that x is a whole number, comma. And so x is a whole number, and those parameters for x are x is less than or equal to 7. That's it. That's set builder notation. X such, in curly braces, x such that x is a whole number. They're all whole numbers, and they're less than or equal to 7. I guess maybe I could say, or I could have said x is less than 8, because then we're talking about whole numbers, and that would be okay too. For B, let's see, what do we got here? What we have, it looks like we have 1, 3, 5, 6, 10, 15, 30. And it looks like 1 times 30 is 30, 3 times 10 is 30. Oh, I realize there's something incomplete in this. Holy cow. Right here, I need to make sure that 2 is inside of this, because this is supposed to be the factors of 30. And it's actually an incomplete list, because I should have put 2 in there, because 2 times 15 is 30. And 3 times 10 and 5 times 6. So, whew. Okay. So we have the set B is equal to curly braces x such that x is a real number. These are all real numbers. Is a real number that is a factor of 30. And there we go. We don't need any more descriptors for that. That's done. Okay. Let's look at number 34. So for 34, these look like integers. They're definitely integers from -2 to 2. So C is curly braces to enter that set. All these x's such that x is an integer. And so the parameters for those integers, so x is an integer. Fine, you can't talk about all of the integers, so we need to put restrictions on this, parameters. And so those integers span from -2 is less than or equal to x, which is less than or equal to 2. So those x's are from -2 to 2. And there you go. And then we have our last little grouping here. Express these in roster notation. And this is going to be pretty easy. N is the set of real numbers that are factors of 20. Okay, so n is, and then open the curly braces. And what this was in roster notation, these right here, these were in roster notation here. So it's just another way of writing the set. So we just need the real numbers that are factors of 20, which are 1, 2, not 3, 4. 4 times 5. 6, 7, 8, 9, 10, and 20. I think that would be it. R is a set of integers that are greater than -3 and less than 1. Okay, so R is that set. Curly braces. R is a set of integers that are greater than -3. So what? That's -2. Because that's the first one that's bigger than -3. And then -1 and 0. And that would be it. I wouldn't hit 1 because it's less than 1, right? So there you go. And then S is a set of whole numbers to 9. Okay, so S is the set of whole numbers. So whole numbers start with 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. That is the end of all the stuff you got to know for this upcoming test. Good luck to you.